air masses and fronts. So let's get to it. So what is an air mass? An air mass is a large body of air that has similar properties throughout. So that means it has the same, relative temperatures, it has the same relative humidity, it has the same things throughout the entirety of the air mass. Now, these air masses form over particular regions, and those regions give them their characteristics. So let's start. Every single air mass is going to have a symbol. That's this first right here, the CP, and then they are going to have particular properties, and they're going to match what that symbol is. So for the C in this stands for continental, and anytime you see continental, that means that this air mass is formed over a continent and it is going to be dry. The second part tells us the temperature of the air mass. So this particular air mass has formed over a pole and it is going to be cold. It's what's known as a continental polar air mass, which means it's dry and cold. We got another couple types of air masses that I want to look at. So this one's CT. So continental means it's dry, it formed over a continent, and it's going to be hot because this one formed closer to the tropics, which is a much warmer region of the planet. Maritime. Maritime is going to mean any air mass that forms over the ocean. This particular air mass is going to be maritime and tropical. So just like the continental tropical, the tropical means that the air mass is going to be warm. It formed closer to the equator and the tropics. So this is going to be a wet and hot air mass because it's wet, it formed over the ocean, or it's wet because it formed over the ocean, and it's hot because it formed in the tropics. Maritime polar is the opposite. Well, not the total opposite, but it's wet and cold. It is an air mass that's formed over the ocean closer to our poles, giving it its properties of being wet and cold. Continental Arctic. So these are forming way up, way close to the poles. These are going to be dry and very cold. They are our driest and coldest air masses. Now here's a map that's going to give you an idea of where these air masses are forming and where they're headed to. That's what these arrows are showing. So our continental Arctic is going to be up here, closest to our pole. Then we have our polar air masses. They're right down here in between our tropical and our Arctic air masses. So we have ones that formed over the ocean. They're maritime polar. That's over here on the west side. And then we've got continental polar, that's our CP, right here in the center, and then maritime polar again over here on the east coast. So you can see they double up. It depends on where they are forming. There can be multiple of each of these different types of air masses. We've got our tropical air masses down here, maritime tropical forming over here in the Pacific Ocean, our continental tropical forming over here in Mexico, and our maritime tropical forming over the Gulf of Mexico. Now, these different types of air masses don't easily mix with one another because they have different properties. They have different densities. So that's going to cause them to be not mixing very easily. In between these air masses, we have these things called fronts. These are transition zones. So we have different types of fronts. And the first one I want to talk about is a cold front. So a cold front is going to bring cold air into an area. It's usually cold and dry air, in fact, is going to move into an area. And it moves faster than our warm air. Precipitation at the head of these fronts can be heavy and very short. And if I look at my map, it's going to be represented by this symbol. But I want to take a look at it from the side. So that's where we're going to see the best information about this. So if I look at my cold front, it's going to kind of be pushing its way through my warm, wet air. And as it does that, my warm, wet air is going to rise up in altitude. It's going to go up into the atmosphere further. Now, we know what happens when things go up into the atmosphere. They get cold. We start to get expansion and cooling. And what's going to happen then is we're going to get to the dew point, and it's going to result in a lot of precipitation. So cold fronts are usually responsible for those short, quick thunderstorms that we see, sometimes in the summertime, or those, quick bursts of snow that we see in the wintertime. What's happening is all that wet, moist air, wet, warm air is being pushed up into the atmosphere, and it's hit the dew point and starting to precipitate. So a warm front is kind of the opposite. It brings warm air, and this is when we get light rain or light winter precipitation. The map symbol right here is these semicircles. This is also in your reference table if you need to know this, but it's going to be represented on the map like that. Air is going to rise along the front, and it's going to cool to the dew point and form clouds. Warm fronts are when we often see multiple days of like overcast skies, right? Because what's happening is that warm air cannot push that cold air out of the way. So as it's moving in, it's slowly rising up into the atmosphere over a great distance. So we usually end up with, sustained light rains and overcast. These are kind of those, low and lousy kind of days when we see a warm front moving through. All right, so here's a picture showing a low pressure system that has two fronts. We've got our warm front here moving to the northeast, sort of like that. We can tell which direction it's moving because the symbol is going to be pointing towards the direction that it's moving in. So, all right, so here we have an example of a low pressure system that has two fronts. So right here we've got our warm front. We can see these half circles representing our warm front, and it is moving towards the north, kind of northeast. And we can tell that by looking at the actual symbols. So the symbols are going to point what direction the front is moving in. Now behind it, we have a low, behind it in our low, we have our cold front. So our cold front is represented by these triangles, and you can see that's moving towards the east. Now, these two fronts are moving at different speeds, and eventually this cold front is going to catch up to the warm front. We've got warm air kind of trapped in between, and we're going to see that's going to form a different type of front called an occluded front. But I want to just point this out. This is how most low pressure systems are set up. They usually have these two kind of arms swinging of different fronts, and as it moves across the country, we get changes in how the fronts are kind of interacting with each other. All right, so let's take a look at that occluded front here. So in an occluded front, the slower warm front is moving ahead of a cold front. The cold front is able to catch up to it, and it kind of pushes all that warm air straight up into the atmosphere. It's represented on our map in this symbol. They're usually purple, and we have both symbols for the cold and warm front kind of crashing into each other. We have another type of front when two fronts are opposing one another. These are called stationary fronts. They are often very slow moving, and they usually bring several days of cloudy and wet weather until the two air masses have kind of equalized out and gained similar properties. These fronts will exist and they can be sustained for a while. They are represented by this symbol, where we've got a warm front on one side and a cold front on the other side, representing the two different directions they were coming in when they kind of crashed into each other. All right, so how are these low and high pressure systems being moved around the Earth? Well, they're being moved by global planetary winds, and one of those is our jet stream, right? They can push our, all right, so how are these low and high pressure systems moving around the Earth? Well, they're being moved by a fast moving stream of air called the jet stream. It's located about 6 to 9 miles above the Earth's surface. So that puts this in the troposphere. What it does to affect weather is it kind of pushes these systems around the world, and that's why our weather is changing. It's moving these air masses, it's moving these fronts, and it's changing the weather as they go around the planet. That's why often here in Rochester, we get our change of weather kind of goes cyclic. We have a couple of, a week or two of warm weather, and then cold weather, and warm, and then cold, and it kind of goes back and forth. And that has everything to do with this jet stream moving those air masses around the Earth. All right, that does it for this video, and we will be moving on to some severe weather next.